Hey everyone, welcome back. For this module, we'll be talking about distribution and composition of populations. Let's begin with the difference between distribution and density. Density is a basic mathematical formula. It's a number of people or animals or things in a population divided by the area that they're found in. Whereas distribution, looking at patterns in a geographic scale, let's say, or spatial scale. There are different ways of looking at or identifying distribution. And one of them here, as you can see, is called a dot density map. So in this case, one dot represents 100,000 people. You can see where people are located in this way. Another way here on the right, you can look at population density and using what's called a choropleth map or a shading map, where each region is shaded based on a category of density. Which one you use makes a big difference in terms of how people perceive your work. So it's really important to think about what methods you are using in a map, which we'll be doing in our lab a bit this week. Here is a shading map based on the geographic unit of measurement is a county, and you can see it's showing us people per square mile in the United States. What's notable about this right off the bat is that there are a lot more people in the eastern part of the United States versus the west, with the exception of the west coast. And so as a geographer, we would ask, why is that? How did this pattern develop? What are the causes of it? Another way of looking at population density today is by simply looking at satellite images of lights at night. Here's an example of the United States, and you can see how easily and how well it mimics the actual data that we have based on the census. There are many ways of conveying this information spatially or visually. Here's an example of what looks like a topography map. Instead of measuring the altitude of mountains and land features, is looking at population distribution. When combined with population density, we get a more accurate picture of the population. So what we're interested in finding out is how people are spread out, where people live. Distribution can be used in a myriad of ways. Here's an example of looking at a disease and where it's found across the Americas. In this case, it's called the valley fever disease. And you can see how useful this would be. Here's an example of looking at distribution of ancestry, African ancestry, American ancestry, and European ancestry in this case. My guess is that American ancestry is referring to indigenous Americans. Here's another look at U.S. population density. This is one way that this map designer chose to display it, and they chose the specific colors, the visual scheme here, the numbers that are represented in each color, which are not displayed. There's no legend here, which is a problem. Here's a better map. This is from the U.S. Census Data Map Viewer, which you'll be using this semester. And you can see that it's just showing the same phenomena, but it is a distinctly different look. First, you notice that it's using a different map projection here. You notice how skewed the two different United States are here. That's also important. If you take a GIS class, you'll learn all about that. And both maps are giving us a good overview of the United States. Again, you can see that discrepancy between how the West is far less populated than the East, except for the West Coast, on both maps here. But with this one, you're getting a much better sense of where urban centers are. You can see all these cities here, Los Angeles and San Francisco, Boston, New York, and so on. If you look at the whole world in terms of distribution, we see interesting patterns develop. There are clusters in the world where people concentrate. North America is one of them here, and especially on the East Coast, from Washington, D.C. to Boston Metro, this whole area is called the megapolis. It's a high concentration of almost contiguous urban area, as opposed to looking at Canada, northern Canada, where hardly anyone lives here, or the center of the Amazon. So we see that North America is very sparsely populated in the north, and it's densely populated along the northeastern U.S. and southwestern U.S. Now we want to ask why. what caused these patterns. That's an important part of a more sophisticated analysis. So we can look at things like transportation, climate, land use, soils, resources, and so on to figure that out. Big as South America, what we see here is we see densely populated regions in certain places and a sparsely populated center. The West Coast is particularly dense, and so is eastern Brazil. And again, asking why, the same kind of question. Here's Europe. You see that Europe is fairly highly dense here, especially we do see the discrepancy again of much less population in the extreme north, but we see that Europe is more uniformly densely populated throughout otherwise. Again, why is that? Here's Asia, and we see two main population clusters: South Asia, primarily India, Pakistan, Bangladesh, and East Asia, China or Eastern China, the Koreas, Japan, and then the countries of Southeast Asia. The center and the north are also sparsely populated. And the question arises again, why? Here's Africa, and what we see here is sparsely populated Sahara, and also the desert here around South Africa, and southern Africa pretty sparsely populated as well, and densely populated in the north and sub-Saharan region. So here in this region along the Mediterranean Sea, and then down here in Southwest Asia, here along the Ivory Coast. Same question. One of the main factors we can look at is the climate. And in fact, if you look at the world's population by latitude, what we see here is that most people live north of the equator. And then secondly, just you see that there's a big drop off as you move southward. And as you get to the southern hemisphere, very few people live in comparison to the northern hemisphere. The tropics represent this area. A lot of people live in the tropics, but not quite as many as live in the northern hemisphere in the temporal region. Another factor we can look at is the economy. Population density and distribution are a factor of resources and also good quality land, particularly in the past. It's not quite as true anymore, and we can ask, why is that the case? And a lot of this has to do with emerging technologies. Another factor is transportation, and what's accessible creates patterns of density and distribution. In the past, a major factor was good harbors along the coast, which is still the case, but not quite as much because, again, we've had a whole score of innovations in transportation. Rivers were also a key factor in the past and still are. Canals came a little bit later, around the early to mid part of the 19th century. A great example of that is the Erie Canal. And then railroads soon after really transformed the landscape, allowing easy access to the interior of continents. 20th century, we see a development of highway systems and air travel, which have really greatly broadened the ability of people to move around and settle. How do we measure populations? Let's look at some different characteristics of the population and also the composition of the population. We already looked at population pyramids, but I'm going to go in a little bit more detail here. It's based on cohorts. You have males and females, and you have age cohorts going from young children down the bottom to the elderly on the top. This is a more classic population pyramid. It's shaped like a pyramid. High number of children because most people are farmers and require the labor. Many less elderly people. So this is pretty typical of a high birth rate country, which there are still some in the world, but not nearly as many. You've gone through the demographic transition model. I just want to quickly review it again. There are 4, sometimes 5 stages, depending on the model. And stage 1 is pre-modern, essentially. And you see the population pyramid is quite large on the bottom. Stage 2 is moving into the modern world, where you're starting to see the very bottom of the population starting to taper off here. This is because there are new innovations in medicine and public health that are keeping children from dying primarily. And then stage 3, we start to see a mature columnar pattern here, where you're still seeing the pyramid on the top, but it's sorting itself out. Many less children are born. We start to see that the age cohorts are about the same. And then stage 4, you see that the birth rate really declines, and you see a declining number of children based on the population average, and particularly based on adults of working age. These are some examples of countries that are represented in these categories. Least developed countries look like this. Most developed countries look like that. This is Mozambique in the top and Iceland in the bottom here. Now you see a country like Bangladesh, which had a very classic pyramid until recently. Now it's starting to taper off and it's losing population quite quickly. So this is typical of a lot of less developed countries today. They are beginning to transition into this pattern. There are a lot of efforts by governments to encourage smaller families, and we'll talk about the reason for that a little bit later. Most developed countries, what we see here is this pattern, as I showed you before. And this has its own set of challenges. In this case, the largest category of people were born 40 years ago. This would be typical of the baby boomers. Here's an example of a mature nation in terms of demographics. The population is declining quite dramatically for the younger generations. The birth rate is decreasing, in other words. And this is becoming a problem because this cohort here eventually is going to move upward and become elderly and leave the workforce. You also see these patterns sometimes where you have very skewed populations. This is typical of a country that has a lot of temporary workers, which are mostly males, like let's say workers in the oil industry. Japan is a great example of this transition. In 2010, you already saw that it had a declining birth rate, and it had been declining for a while, but you still see this kind of column there with a little bit of divergence here. Projected in 2050, you see that it's a reverse pyramid, where there's a very, very small number of children in comparison to the elderly, which is a huge challenge for this country, or any country that goes through this. India is more typical of developing countries. So you see this is a classic pyramid just as recently as 2010. And by 2050, we're seeing a columnar shape. So just a quick recap. Least developed country. A country that's moving into the world is beginning to be urbanized, is starting to industrialize. A country that's been doing that for a while. It's starting to move into the fourth stage of the population and just about there. And then here's a country that's more mature in terms of the economy, in terms of its demographics. The other thing we're interested in when we're looking at these population pyramids is sex ratios. And the number of males per females is one way to measure that. If it's greater than 100, it means there are more males than females. If it's less than 100, it means there are more females than males. So you can, in this case, you see that there's more males in this society. This is Bahrain in 2005. And in this case, the bottom here, you see more females in the society. And this is Estonia. And you have to ask, why is that? What are the factors that are contributing to these discrepancies? It could be death rate differences, it could be migration, it could be birth and newborn infant differences, or maybe other factors. If you look at the child sex ratios worldwide, you see something quite interesting. And you see that there are more males children than female children in many places, except for one or two countries here. And the reason for that primarily is that biologically more male children are born than female children. It's a small percentage difference, but it does add up. There's a lot of theories behind this. Male children tend to be more fragile. They die a little bit more frequently as young children, and so more are born to compensate for that. In some cases, it has to do with politics and culture as well, like in China, for example. And you can see it in India, and you can see the differences there that really pile up culturally. So that's what means a preference for male children for various reasons. In the United States, what you see is that there are more females in the East and more males in the West. Largely, this has to do with the fact that this area has been settled for much longer than this area. And there's a lot of people moving out to this area and they're younger. But this will be a great, say, paper to do in this class to figure out why we see this pattern. There's many, many different reasons, and there's some controversy as to why. Another way of looking at it is to look at the median age of a country. Here's the United States, and again, what you're seeing is that the Northeast is pretty old. The East in general, and the North is older than the West and the South. It tends to be younger. A lot of this has to do with the history of migration. Here's a map that really illustrates that. The mean center of population, the geographic center, has moved from just east of Washington, D.C. in 1790 all the way out to Missouri. So it's moving westward mostly, and also east Tennessee. By the 20th century, it's taken a southward dip as well. The population growth has been greater in the west and the south, and that's been consistent for a long time now, for many, many decades, and that's contributing to this shift, as you can see here on this map. Another way of illustrating this pattern is by looking at where the population is changing, percent population change by county. It gives us a similar look, but you can see that there's differences in how it shows on visually. And again, this is a choice that the map maker made, how they chose the categories and the shading factors, which I really will want you to play with in this lab coming up in this module. All this leads us to look at dependency ratios. The changes in the characteristics of the population have a profound impact on society. What we want to look at is the workforce in comparison to children and retirees. The dependents are people who are not contributing economically to a society and that require resources from those who are contributing to society. There are three different ways of measuring these. One is to look at children, one is to look at elderly, and then the third is to look at both categories, children and elderly, together. How you calculate these dependency ratios is pretty straightforward. The young dependency ratio is the population under the age of 15 divided by the population of working people, 15 to 59, multiplied by 100. Old dependency ratio is the elderly population, 60 plus, divided by the working population, multiplied by 100. And then the total dependency ratio is both children and elderly populations divided by the working population multiplied by 100. Now these numbers, 15, 59, and so forth, can change depending on who's doing it, but they're roughly in that area. The dependency ratio is a ratio of the dependent age population, young and old, to the working age population. So for every 100 people who are working, how many people are dependent is one way of putting it. Here's an example of Canada, and you can see in this light blue line that this is the population pyramid of Canada, and it gives us the percentage of different cohorts based on dependency. 16.5% are children, 15% are elderly, and about 68% are working age. The terminology can get a little weird sometimes. The age dependency ratio sometimes is used. Total dependency ratio is sometimes used, and sometimes just saying dependency ratio, and they all mean the same thing. Typically it's referring to elderly and children combined in comparison to working age populations. Here you can see the world as a whole, and so around 1960 there's a huge spurt of growth. The birth rate was super high. The dependency ratio was high because of the children, number of children. Now as that has dropped off, the dependency ratio has gotten improved, it's gotten better, until about 15, 20 years ago, where it began to go up again because of the elderly population increasing rapidly. Looking at it spatially on a map in 2017, you can see that age dependency is really an issue for sub-Saharan Africa and a few places elsewhere in the world. Here's a more detailed map showing total dependency ratio in the world. And you can see that Africa really stands out. A few other countries like Afghanistan up here, some part countries in the Middle East, and a few places in Latin America are still showing quite high dependency ratios. Whereas you look at Europe, it's fairly low in some places, but also quite high as well for the opposite reason, that there's a lot more elderly here. This is more due to children down here, this is more due to elderly. In the United States, it's kind of a mixed bag. Let's take a look at three specific regions and countries. Here's Europe in red, and looking at dependency ratios. You can see that the elderly dependency is really taking off here. United States is similar, although not quite as much. And you have to ask yourself, why is that? What's going on here that's making this shift? Both the United States and Europe are highly developed areas. So what's going on? Well, part of the answer is that the United States life expectancy is just declining right now, becoming much less than it is in other developed countries. Again, that's a great question. We want to know why that is. We make a great paper. And Japan really stands out where it's the same as the rest of these, but more extreme. You can see a really big factor here. The one difference you see here is in the 1940s and 50s, Japan had a lot more children because it went into the fourth stage of the transition model a little bit later, but then it accelerated through it faster than the rest. Here's an example of some basic calculations. Again, these numbers can vary. Sometimes it's 14, sometimes it's 15, sometimes it's 18, but typically 1 to 14 is common, and 60 plus is common as well. And so children plus elderly, total number, and then working age, multiplied by 100. Very straightforward. So in this case, there are 19.3% of children, 14% are elderly, 66.7% are workers. Plug those numbers in and you get 49.9%. So for every 100 workers, there are 49.9 dependents. Looking at Europe, which is quite advanced economically and demographically in this case, you see how much the difference is between 2010 and the projected 2060. So a lot of countries in Europe are going to see much larger old age dependency ratios than they have today. And these nations are already quite stressed. You're seeing them having to pull back on their benefits because they just can't keep up to take care of the elderly as well as they did in the past. And you're seeing this leading to a lot of political change as well. The opposite problem is in the developed world with child dependency, especially here in, again, sub-Saharan Africa. And in this case, what you need is children require lots of services, education, health, all kinds of things that are resources that these countries that typically are quite poor struggle with. Looking at the U.S. dependency ratio in the United States, you see again, child dependency is quite high in some areas of the country and quite low in others. You see these patterns are repeating themselves. They're really showing up in the different ways we are measuring them. Lastly, we'll talk quickly about life tables. And insurance companies will use these quite often to figure out how much to charge people for life insurance. They're used in many other ways as well. But essentially, the way this works, if you happen to be 60 years old and you're male, your probability of dying that year are 0.017161. And if you're female, it's 0.007219. As you age and you make it through life, what happens is that your life expectancy goes up. So the overall life expectancy of men can be, let's say, 76. But if you're already 65, then your life expectancy is probably going to be closer to 80. Graphically, this is what it looks like. Okay, life expectancy increases with age achieved. So here's males and females. Somebody who's 80 years old is likely to have a life expectancy of about 90. So another way of looking at the same data is remaining life, how much life you have left. Again, the older you get, the more that increases. I hope this was helpful. Let me know if you have any questions. I'm always available to meet one-on-one, like a video conference, if needed. Thanks.